Hello, my name is Danko Emmanuel Kenjo, and I welcome you to Kentech 96 TV. Today, we'll be looking at what we call Ohm's Law. So, when we talk of Ohm's Law, it is being applied in circuits. So, when we talk of the Ohm's Law, it states that the current passing through a conductor. So, if you have a conductor, definitely there will be a free electrons, and these free electrons carries what we call charge. So the rate of flow of electric charge is what we call current, and the current will flow from a higher potential to a lower potential. So the current which is flowing through this conductor is directly proportional to the potential difference. Remember, the current will flow from a higher potential to a lower potential. So the potential difference which is applied across the conductor, provided that temperature remains constant, is directly proportional to the current. So we can say that current is directly proportional to V. So this is the symbol of proportionality. Then we can also say that the voltage is directly proportional to the current. Now, as the current is flowing through the conductor, definitely there will be what opposition to the flow of electric current, and that opposition to the flow of electric current is what we call resistance. So here we can say that I is directly proportional to current. Then we need to change this constant of what? Proportionality to an equal to sign. So if it is dimensional analysis or variations, we will have used K. But here we are saying that V is equal to Ri, whereby this R is the resistance to the opposition of flow of the electric current. So since multiplication is commutative, we can simply say that our V is equal to IR. So anytime I want to calculate what the potential difference across a conductor, I can simply multiply what the current which is flowing through the conductor times the resistance which is the opposition to the flow of current. So V is equal to IR. So let's solve one question using the Ohm's law theory. So from the question, we have an EMF source of 6 volts is connected to a resistive lamp. So this is the load, a resistive lamp, the load, with a current of 2 amperes. What is the resistance of the lamp? So if you are supposed to have this simple circuit, this is my 6 volts. So we have a resistance here, and we have the lamp. Then a current of 2 amps is what is flowing through the electrical lamp, the load. Now we want to calculate the value of what? The resistor. That we want to calculate the resistance. Then from Ohm's law, V is equal to IR. Therefore, my R will be equal to V over I. So this 6 and 2. So if I divide this, I'm going to have 3 ohms. Resistance is measured in ohms. So the resistance of the lamp, okay, is what we call, the resistance of the lamp is 3 ohms. So let's finally talk about power and energy. Energy is the ability to do work. So for an electrical circuit to perform a given task, it requires what? Energy. So per the definition, energy is the ability to do work. Now let's look at potential difference. Remember, we said what? If you have a conductor, this is one end, and this is the other end. And charges will flow from what? A higher potential to lower potential. So potential difference between 2 points is defined as the work done when 1 coulomb of electricity moves from one point to another. So here, to calculate the work done, a potential difference must be applied across what? The conductor. So if a potential difference is applied across the conductor, then definitely charges will move. So if you want to calculate the work done, remember here work done is the same as energy. So the work done will be equal to your potential difference, which is across the conductor times what? Charge. So we can have W to be equal to V Q, where V is equal to what? Charge. Then from when we were looking at electric current, we said what? Charge is equal to IT. So definitely here we can say that our work done or energy is equal to VIT. So if I multiply my potential difference times current times time, it will give me what? My energy. So to calculate for energy, you need your voltage, you need your current, and you need what? Time. Now from Ohm's law, V is equal to IR. Therefore, I will be equal to V over R. So if I is equal to V over R, if I substitute this value into this equation, then work done or energy will be equal to V square times T all over R. So let's finally talk about power. Then with one example, we can end this session. We are saying that power is defined as energy used per second. So power is equal to energy used per second. That is time. So per what we did previously, we said what? Energy is equal to IVT. So substituting this into the power equation, we are going to have P equal to IVT all over second. So second is what? Time. That is the unit of time is second. So T will cancel T, giving us P equal to IV. So in a circuit or whenever you want to calculate power, just multiply current times what? Your voltage, and it will be equal to what? Power. Then from Ohm's law again, we said V is equal to IR. So substituting this into the power equation, we are going to have P equal to I square R. Then we can also make I the subject here and substitute it into the power equation. So I is equal to V over R. If I is equal to V over R, then the power equation will be equal to V square over R. Okay, so an electric kettle operating on 100 volts, so the supply voltage is 100, uses 2 kilowatt power. Now remember, kilo is times 10 raised to the power 3, so this is 2000 watt power. Calculate the current in the circuit. So if you have a circuit, this is the 100 volts. Have a resistance here. So this is the load, and the load here is the kettle. So to calculate the resistance in the kettle, then we have to now calculate what? The current first. So what is the current which is being produced by this source voltage? Remember we said what? Power is equal to IV. Therefore, I is equal to P over V. So the power here is 2 kilowatts. In other words, 2000 watts. Dividing the voltage, the supply voltage is 100. So this cancels this cancels this. Then the supply current or the current in the circuit will be equal to 20 amps. So here we are having 20 watt amps. Now what is the resistance of the kettle? We want to calculate what? The resistance of this kettle. Then from Ohm's law, V is equal to IR. So the resistance will be equal to V over I. The voltage, supply voltage is still 100 volts. The current is 20 amps. Therefore, the resistance will be equal to 5 ohm, because 0 cancels 0, 2 goes here, 1 goes here, 5. So we are going to have 5 ohms. Now, what is the energy consumed by the kettle in 24 hours? So remember, we said what? Energy is equal to your IVT. Now, this IV is power. So energy is equal to power times time. The power is 2 kilowatts, and the time used is 24 hours, which is within 1 day. So the energy consumed will be equal to 48 kilowatts. But you can also convert this 24 hours into what? Seconds. Then you multiply it by the power. It will still give you your energy. So the energy consumed within the 24 hours is 48 kilowatt hour. And the hour is coming from the 24 hours. Thank you for watching Kentech 96 TV. And please, if you are new to this channel, kindly subscribe for more updates. Thank you.